to our last panel. Welcome back for our next talk. My name is Anna Sher-Wilson, and I am the Program Specialist for Career Navigation here at Women Who Code. I'll be leading part 2 of the conference, but right now I'm really excited to introduce our next speaker, my friend and colleague, Zarreen Reza, who's going to talk about mistakes to avoid as an AI practitioner in industry. So a little bit about Zarreen. Zarreen currently works as an AI research scientist in Volta Charging in Canada, where she takes delight in working at the intersection of high quality research, data science, and applied machine learning to produce innovative machine learning solutions for EV charging stations. Aside from her role as an AI scientist, she also gets involved in many open source projects. Zarreen is also a leadership fellow at Women Who Code, where she leads the data science track in organizing free events, workshops, and building a community that helps women excel in STEM roles. And to top it all off, she likes to start her day with 10 minutes of yoga and a cup of hot chocolate. So welcome, Zarreen. Let's all welcome Zarreen. I'm going to leave the stage and I'll be back for the Q&A at the end.
Thank you so much, Anna, for the amazing introduction. I'm very excited to be here as a speaker. So hello, everyone. I'm Zarreen, and as Anna mentioned, I'm working as an AI research scientist in Volta Charging. Before that, I worked as a data scientist for 2 years in another company. And before that, while I was in academia, I worked as a research assistant where my lab used to collaborate with some industrial partners to deploy our prototype models that we used to build to their platforms. So I have all these different stages that taught me that there are a lot of things that are different from academia to move to the industry. So in academia, we can have the coolest model, the state-of-the-art model at our disposal. But when we want to deploy to the production or move it to the client's premise, things gets more complicated, and there are a lot of restrictions, constraints that need to be taken care of. So today's talk is mostly about sharing my experience, some of the mistakes I did by myself and then learned the hard way, and some of the things I learned by seeing others. So all these things are basically what I'm going to tell you today is these are mistakes to avoid if you want to be an AI practitioner in the industry, especially if you are coming from the academia mindset. So let's get started. First of all, the problem with today's AI solutions in the market is quite acute, in a sense that around 90% of total machine learning models that we build in a company or in a research lab, they don't make it to the production. So in other words, it's the same as saying like 1 in 10 of a data scientist AI solutions end up not being a part of real product. So 1 in 10 of data scientist AI solutions end up being a part of products. So 9 of the data scientist solutions, that means they either get discarded or discontinued, or they have to pivot. So what are the bottlenecks in this entire process? Why is this the case? So today I will highlight 12 mistakes. So there can be more, but these 12 mistakes I found like they're really crucial to avoid if you want to make a successful deployment to a production of an AI-based solution. So let's get started with the first one. First mistake is considering that every data problem requires an AI ML solution. So in today's market, AI is a hype word, it's a buzzword. So everyone is really hyped up to try some new algorithms, that's all the state-of-the-art algorithms, and try to solve all the problems. So there is a common saying in the AI world is that when you have a hammer, everything looks like a nail. So when you have a hammer, when you know you have the AI skills, you have the resources in your team, you feel like you need to solve all the problems through only an AI algorithm. But that's not necessarily true all the time. So the thing is, not every problem requires an AI solution. Sometimes the rule-based algorithms are much better than these complicated AI solutions for various reasons. But it depends on the case itself. It depends on specific case, specific requirements, their constraints, all different things. And AI solutions are not the only solution to all the problems. We are still not there. Maybe one day we will get there where an AI will be as sentient as human and will be able to solve everything, but we are not there yet. So what is more important here is that finding a practical and efficient solution, which should be the goal. So please focus on the practical part here, because uh, many of the AI algorithms, which are like all those very deep neural networks, they are not always very practical to use for real world use cases. There could be memory inefficiency, there could be time complexity. The deep neural network may take forever to give you inference. However, you need like an immediate response. So all these things that needs to be considered before deciding on an algorithm. And the goal shouldn't be like, let's attack all the problem with an AI algorithm. The goal should be finding a practical and efficient, the most efficient solution you find for your business use case. So there are a few action items that you can consider taking in this case. So first, ask yourself this question, ask your team this question. Are you trying to solve your business problem using the most effective method and also maximizing on the savings and profits? If the any AI algorithm or any algorithm, whatever fits inside this question, you are good to move forward with that. Then you also need to decide this approach on case by case basis. So there is no free lunch in the AI field. So one algorithm that works for one type of problem doesn't necessarily need to work as well for other problems, even for similar problems sometimes. So we need to decide what approach we need to take on case by case basis. Also, don't shy away from adopting non-AI solutions. This is really important. I like to stress on that more, because in a practical world, in real world, when you are thinking from the product point of view, it's very tempting to talk about AI, because when you are marketing your product, you want to somehow plug in that word like we have an AI powered solution. So that's really good for marketing. That creates the buzz. However, if eventually the product is not working as expected, if it's not serving the customers that it was intended to, then all these things, it will slow down, it will die down eventually, right? So it's better to consider the algorithm, uh, consider coming up with the solution itself instead of AI power or non-AI power solution. So just think of it as what is the most efficient and most practical solution. And finally, just don't buy into all the hype that's going on around AI. So I know I'm saying this as an AI research scientist by myself, but that's why I'm telling this to you, that there are a lot of problems in today's day that are so efficient, but still they don't use any AI solutions. So AI problems are really good for a certain type of problems, but they are not as good as some other traditional rule-based algorithms or other semi-automated solutions that we have in practice today. So not everything has to be solved with AI. That's the bottom line. Mistake number 2. Domain knowledge can always be compensated by data science skills. This is again another misconception. It's tempting to think like we can let the machine learning algorithm figure it by itself, the solution, all the things. But you will be surprised to know, like, domain expertise or domain knowledge in data science is really crucial. It's even more important than other tech related roles because of varieties of reasons. And for that, domain knowledge must be pervasive throughout the data science methodology. So starting from data collection, data preprocessing, till the model development and validation, plugging in domain expertise will save a lot of your time and resources. Otherwise, you will be spending hours after hours cleaning those data, processing those data, because you have to figure everything by yourself. But when you have a domain expertise, domain knowledge, or a person with domain expertise, they can easily guide you and navigate you to the direction. Eventually, the data science skills, the data scientists will be the people who will be working on that. But if they are guided or navigated in the right direction by some domain experts, that will save a lot of time and resources. They can help navigate the problem definition as well. As example, what type of problems that exist in that particular domain. So if it's like a medical domain, it's a finance domain, legal domain, the domain expertise will have better understanding of the problem and what type of solutions they are looking for. And they can help really so much in cleaning and preprocessing the ugly data. So in real world, the data set is lot more different than the curated data we have in academia, like all those open source database data sets, the data sets we have in Kaggle. They're really clean, pretty, curated, but it's totally different case in industry, in real world, where the data set are really raw, ugly, and sometimes the data set is totally not the data you need for your model. So there are a lot of different things, but you can overcome these challenges pretty quickly with the help of a domain expert. And finally, the domain expert can also help validate the results that your model are providing. So when your model are making predictions, domain expert can actually take a look and say if these results make sense or not. So you will do your own validation analysis from data science point of view, but from practical point of view, it will be the domain experts who will be able to tell you much quicker that, hey, this result looks good to me, this result doesn't look quite there yet. So what are the action items here? Again, obviously, try to include domain experts whenever possible in your pipeline. Run frequent check-ins with them whenever you pass like a certain stage. Let's say you are done with the data pre-processing step, just do a check-in with the domain experts, just run through them, all these things, if it makes sense. And you can facilitate understanding of the client's need more by using domain experts. So domain expert can actually talk to the client and better understand their need, better understand their problem. And finally, one important thing is data science skills and domain expertise can be mutually exclusive. So it doesn't have to be like the data scientist coming with the domain expertise. It's not necessary. The data scientists can be really good at their data science skills, their AI modeling skills, but it's not necessary for them to have the domain expertise as well, because sometimes it's really difficult to find this combination all the time, and that's totally okay. They can be two different people, but they can work collaboratively to overcome these challenges. Mistakes number 3 is ignoring AI ethics, bias, and privacy considerations. Now, I will tell you why this is really important, why it's crucial to address these ethical and privacy concerns as early as possible in the beginning of your model development, when you're defining problem, when you're defining data curation, why it's important to address them. So there are privacy, bias, inequality, safety, security, all those things, all these concerns are going around these days about AI solutions, especially if they're in the fields of medical, finance, all those very sensitive areas where people don't tend to trust the AI solutions or algorithmic solutions as much as they trust human decision maker. So this is really important to think about ethical and privacy concerns, because all these trust issues, they're coming from there as well. So the AI models, they should not be in favor or in against of a certain group. And if you neglect all these aspects before starting the model development, they can lead to significant financial, brand reputation, and human risk. So you can eventually, like maybe at a later stage, you will have some financial repercussions because of these things not handled before. Your brand reputation can be in jeopardy. And most of all, most importantly, we are dealing with humans. So all these AI algorithms, they tend to serve human. If they are not solving problems for human, rather creating more problems for a subgroup or for a certain problems, then that fails the whole purpose of building AI solutions, right? So it's really important to address those issues as early as possible in the development phase. So some action items could be to address this risk right from the data collection and curation. When we are doing the data collection, it's really important that the data is diverse enough to fit the problem, that fit the data that we will see in the real world. So there are a lot of talks around that topic, so I won't go too much into that detail. But you should also think through the possible ways the model can be exploited or used in favor of or against a subgroup. So this type of analysis, this type of brainstorming is really important to do, like how this model can be exploited, if there are any risk of that or not. Also, if possible, run experiments to identify information leakage from model through reverse engineering. So there are a lot of experiments these days that shows that even if you just make the trained model available to the public, there are ways that you can actually reverse engineer. You can backtrack the weights from AI models and come back to some identifiable informations hidden in the data. So that could be pretty scary depending on certain fields. So this is something that needs to be taken care of, that needs to be thought of. If possible, there are multiple tools to actually validate all those things, diagnose these problems. So please try to leverage them as much as possible. Leverage the privacy preserving AI tools where required. So there are tools like federated learning, differential privacy, all those things. So they're all out there, but you need to just make sure that you are incorporating them in the right time for the right problems. Mistake number 4 is complex models are better than simpler models. So that's not necessarily true all the time because of several reasons. So if you have heard about Occam, William Occam, so he has a very famous hypothesis, which is famously known as Occam's razor, that suggests that simpler models with fewer coefficients would be preferred over complex models like ensembles. So basically, what Occam has to say is that if you have similar platforms, you have similar parameters, similar hypotheses, then the one with the simpler parameters are better than the one with the complex parameters, because of different reasons. So I will tell you why this is the case and why this is a general statement, but this is very much true in today's machine learning development, where state-of-the-art models are not always feasible for practical use cases. So, as example, in current state-of-the-art models for image classification, or let's say all those generative arts, right? Those transformers, they are huge models with billions of parameters. Now, big companies, big research labs can afford to run those algorithms, train those algorithms on their hundreds of GPUs, but that's not a practical to use for others, for let's say small companies, or even in your client's laptop, right? If you want to make a product that needs to run that big trained model, maybe on any of the edge devices, that's not a practical solution because your client may not have those resources available. So simpler models can also be easier to debug and run experiments faster. So if you want to do a lot of trial and error in the beginning while you're developing the model, simpler models can let you try out a lot of different things in a very short period of time. Whereas when you have a very large complex model where finishing of one training requires maybe 5 to 6 days, then it's really difficult for you to try out a lot of combinations because you are losing time. And finally, simpler models are much cheaper to deploy and scale uh, because of similar reasons. So complex models require more computational resources, more cost. So as opposed to simpler models, you can just make like an API, or the trained model also, if you package it if you package a random forest model, you can deploy it in almost any edge devices or in almost any cloud servers. But if you have a very complex, very deep neural network, as example, you need specific GPU based systems at least to make the best of it. So some action items there could be: always start with a simpler model before moving on to deep learning. So maybe you can start with linear regression or logistic regression, or even try gradient boosting if you if you think that you need more a bit more complex models to start with. So you should first start with all those things, because then you will get a better idea like why these models are not working and in what places we need to improve. Should we improve on the data, or should we improve on the parameters? Should we improve on the feature selections? All those things. So you will be better prepared when you are moving on to the deep learning models, and it will also reduce the number of experiments you need to do, because you already have some insights about the problem. Also, have a baseline model to compare against. So your first simpler model, the simplest model, could be actually used as a baseline model. So when you are moving on to more complex models, you can easily compare like how much improvement you have obtained through this by adding this additional complexity. Also, try to avoid ensemble models. So if you see the research papers, there are a lot of solutions that they propose is they're all based on ensembling models. So when you ensemble multiple models and you take maybe the average of the predictions, they tend to perform much better than a single model, for obvious reason, because there are a lot of like multiple models are at work on the same problem. However, if you so these are good for results, these are good for academic papers, because you always pass the state of the art result and you can set the new benchmark. However, if you want to deploy them into your production, uh, this is not really an efficient or practical way of uh, deploying the solution, because then you not only need one model, you need to deploy maybe 5 different models. So the 5 different models need to parallelly make the predictions, and then you have to aggregate them in some way and then provide the inference. So you can see there are a lot of time complexity there, memory complexity there. You need to basically register all 5 models in your device before it starts making the prediction. So it's much different, much difficult than having only one model. So try to avoid ensemble models whenever possible, and also consider memory and time complexity requirements for inference. So training and inference are 2 different things in machine learning, as you can see. So sometimes training your model can actually be done on a more resource intensive platform, like you have more GPUs in your infrastructure, you train your model there, all those things. Then you package the model and you ship it for inference to another platform, let's say your client's platform, your client's phone, or your client's own server. So it's really important to know like inference needs to be faster, inference needs to be maybe CPU compatible. If your inference also requires like 100 GPUs run together, then it may not. It's a good sign that it may not be an efficient solution to be deployed in the production. So you need to think of training and inference separately. Like what are the infrastructure requirements for training a model versus what are the infrastructure requirements for making inference using that model. They can be different. A model can be much slower while training, but the model can be much faster during inference. So these are the things we need to take care of. Mistake number 5: consider your AI solution as a black box. So this is a very common scenario, common saying in AI field, that AI solutions are a black box. It's really difficult to interpret the result, understand what's going on inside, all these things. These are really true. These are all true. However, when you're you're transferring this model to a set of people who are not as well versed in AI as your data scientists. The transparency and explainability, interpretability, all these things become really crucial to earn their trust. So for that reason, we need to set our mindset to so that we transition from black box to glass box modeling. So glass box I mean, we need to do some peeking. We have to peek inside the model, what's going on as much as possible. There will be like some things that are still really difficult to interpret, especially if there are really complex models, deep neural networks. There sometimes it gets really hard to understand why this model came up with this prediction over another one. But still, there are a lot of tools these days. There are a lot of research. It's a very active area of research, which is explainability in AI. So please try to leverage those tools as much as possible, depending on your problem, depending on your model. So explainability goes a long way to build trust on AI made decisions. So your clients, your partners, your people will trust the AI made decisions more if they know how the model is coming up with the solution, right? So this is really crucial to even sell your model. Finally, interpretability of result helps debug and identify potential harms as well. So this is also important. So when you have a model which is totally black box, you have no idea what's happening inside. You just know that some inputs are going in, some outputs are coming out, but you don't know what's happening inside. So when you are not getting the expected outputs, it's really difficult to debug and understand why, like what is going wrong there and what are the things that needs to be fixed. So if you have some interpretability analysis of the results, then it makes it also much easier to debug and fix that model. Also, it ensures ethical decision making. So as I was talking about ethics and bias in the previous slide, so this also ensures that the model is taking ethical decisions. It's not being biased towards a certain group or certain scenario. So what are some action items? Use model explainability tools like Lime, SHAP, etc. As much as possible. There are a lot of libraries these days. These two are pretty commonly used, but there are a few others that's coming out. They're pretty good in terms of they give you some way of checking the feature importance, the feature correlation with the prediction, and all those things, a lot of other things. So try to leverage them as much as possible. Then decompose a complex model into simpler segments. So again, having a simpler model will come handy to do this explainability analysis. So if you have a very big deep neural network, very big AI model, try to decompose them into simpler models so it's easier to debug. It's easier to analyze or interpret their results. Also put constraints on the model to add a new level of insight. Maybe restrict the model at first so that it doesn't go to multiple directions, so that your horizon gets enclosed by certain restrictions. So you don't have to try all the combinations to come to analyze the prediction. So you will have less parameters to deal with. So try to constrain the models at first to see how the model performs at the very restricted scenario. Also run both quantitative and qualitative analysis of the predictions. So quantitative analysis is basically doing precision recall curve, AUC curve, doing all those analysis, if the model is performing well on the positive classes over the negative classes, all these things. But also we can do qualitative analysis of predictions where we kind of manually go through each prediction to reason ourselves, like what the model is learning actually. Is it learning really something useful, or it's memorizing, it's being overfitted, all these things. So it's important to run both quantitative and qualitative analysis of predictions. Mistake number 6 is emphasize model-centric AI over data-centric AI. So if you follow Andrew Ng, who is a pretty known figure in the AI community, he is advocating for data-centric AI these days quite a lot. So what data-centric AI means is that data-centric AI requires a heavier focus on tuning data rather than tuning models. So we spend a lot of time doing trial and error, hyperparameter tuning, all these things to come up with the best model to make the model learn the most useful things. However, what Andrew has to say is that most core AI models are already well tested and available to use. So maybe it's not always worth the effort to put a lot of resources, a lot of time in coming up with a new algorithm. We don't always need to reinvent the wheel. Sometimes we can just use these off-the-shelf AI models, and they may work just fine for your problem. So instead of spending a lot of time tuning those neural networks and tweaking hyperparameters, you can spend more time on tuning the data, because that's where you can improve a lot. So it can also help reduce the small data problems as well. If you don't have a lot of data for your problem, which is very common in real world, so if you don't have that, uh, data-centric AI or tuning your data can really help coming up with a very good model. So what are some action items? Try to figure out the ideal set of data required for the problem. So when you are defining the problem, what is the ideal set of data that you need? First, define that. You may or may not have the exact set of ideal data set, but that's fine. But you know, like what is your expectation, what you need ideally. Check data quality to detect human error in curation and labeling. So data are they at the first place, they are labeled by human, they are curated by humans. So the most of the errors comes from that stage. So it's really important to do some quality checking of the data while it's coming. Also, collaborate with domain experts and data scientists to improve the data quality. So here again, the domain experts can really help. They can collaborate with the data scientists to improve the data quality, identify the false labels, all these things. Also, try to leverage the pre-trained models where needed. There are a lot of pre-trained models available, open source, for you to use, to try with. So let's maybe just first try or start with them, focus on the data first, and try with the off-the-shelf models. If they don't work, then focus on the model tuning. Number 7, treat AI model development projects same as software development projects. This is a major mistake, I feel, and I have seen this mistake being done firsthand and what the repercussions were. So software engineering and machine learning are different in their execution. So software developers automate tasks by writing programs, whereas machine learning or computer science or machine learning engineers or data scientists, they try to make the computer find a program that fits to the data. So there are, like you can see, in machine learning, it entails a lot of exploration, experimentation, and uncertainty. And it also needs to be robust to variability and dynamic conditions as well. So it has a lot of uncertainty in its nature. So what are the action items? So while planning the model development, keep the buffer for uncertainty, keep certain amount of buffer that some things can go wrong, and also allocate time and resources for doing research. So encourage your data scientists, AI scientists to do some research, because they will know what is the current state of the art model, what is working for a certain type of problems, what is not. So please allocate time and resources for them to do some research. Also, be prepared for failed experiments and inconclusive outcomes, because this is very normal. It can happen in machine learning. It is another difference from software engineering, where all the problem, the requirements all are well defined, while in machine learning they are not always. So let's be prepared for that. Also, be prepared to pivot as new findings surface. So in machine learning, as there are a lot of uncertainties, there are a lot of variabilities, things can go wrong, or things can go the way you're not expecting. So it's always always the best to prepare to pivot whenever possible. So instead of pushing on a certain model for more and more accuracy, you can take few steps back and think, okay, why it's not working? Maybe this is not the right approach at all. Maybe something we need to try something else. So try to pivot as quickly as possible. And finally, mistake number 8, not adopting test-driven development in data science where required. What does that mean? So test-driven data science, this concept is getting quite popular these days. This is a skill data scientists and machine learning engineers can adopt from the software developers. So TDD system, it has 3 stages: red, green, and refactoring, where in red, you write a test case that fails. In green, you write the code that passes that test. And in refactoring, you try to get rid of all the redundancies. You try to modularize, clean your code, make the code reusable, all these things. So writing these test cases actually forces you to think about what scenarios users might create later on, what type of variations we can expect in the input data. It also helps modularize your code base for reusing functions and for future expansion. So if there's a possibility, like in future, your model needs to be extended for a certain type of features, for a certain type of data set, this kind of TDD based system will really help you do that. Some action items could be: break the AI pipeline into smaller modules, write test cases for modules covering data variation, exception handling, anomaly detection, all these usual things. Have your codes reviewed by your fellow data scientists, and encourage collaborative coding and sharing of ideas among them. The last 2 steps are really important. It's very normal for data scientists to work in their silo, work on projects as an individual, as a only person assigned to that problem. But doing code reviews like software development, doing machine learning code reviews is really, really helpful. It helps the data scientists to think out of the box, also think more clearly. So this kind of idea sharing and code review, it's very important. Now, I know we have already covered 8 of the mistakes. There are 4 more because I told there will be 12. So I won't go on too much detail in the last 4, but I will just skim through them. Basically, mistake number 9 could be skipping the proof of concept and MVP stage to directly jump onto the production. Mistake number 10 is not defining the infrastructure requirements before or during model development. I kind of touched this little bit before when I was talking about what are the infrastructure required for inference on the client side. This is really important. Number 11 is moving on to production before pilot run and expert evaluation. And number 12 is no plan for systematic model monitoring. This is very important because if you don't monitor your model, there will be data drift, model drift while the model is in production. So if there is no mechanism for continuous monitoring of your model, you will not know when the model has started deviating from its original performance, when it's starting giving anomalous results. So this is also very important. So just as a recap, every data problem doesn't require an AI ML solution. Domain knowledge cannot always be compensated by data science skills. Don't ignore AI ethics, bias, and privacy considerations. Complex models are not always better than simpler models. Try not to consider AI solutions as a black box. Emphasize model-centric AI as well as data-centric AI. Continuing, don't treat AI model development projects same as software development projects. Try adopting test-driven development in data science where required. Don't skip POC and MVP stage to production. Define infrastructure requirements before or during model development. Don't move to production before pilot, and have some plan for systematic model training. So that was all from me. Thank you for listening to me. And if I have some time, I can take some questions.
Thank you so much, Zarreen. That's right. We have about 4 minutes for questions. So if you have any questions, please put them in the chat and I can get them to Zarreen. Before we get into the questions, we just had a quick question about one of the slides, Zarreen, from Angela. If you could go back, can you just re-show the privacy preserving tools before your Occam's razor slide. That would be great as we start gathering some questions. Thank you, Angela. Okay.
Yeah, let me just find it quickly.
And Angela says thank you.
Privacy and ethics, I think.
Yes, yeah, yeah. Okay. Right before that one, she said.
This one, right?
Yes.
What was the question again?
She just wanted to double check privacy preserving tools where required. Just take a screenshot of that. Wonderful. So to wrap up, I have a question, kind of as a final thought to leave everyone. But one of the reasons you did this talk was because you felt there was a gap between when you studied and actually practicing. So as we conclude, do you have any advice for people who are studying or who are in academia? Like, how do you transition? Yes, and Michelle just asked, what do entry-level interns or people lack before starting their first jobs? Yes, thank you, Michelle. That's exactly what my question was as well. So what can people do while they're studying to bridge that gap?
Yeah, that's a great question, and this is like a very important question that's been asked so many times. So I think it's it's really important that you do all those Kaggle competitions, or you work on those open source database which are really clean and curated. It help you grow all those necessary skills, like your data science skills. But to make you prepare for the real world, you need to work on some real world projects. So what you can do is you can come up with your own project. You can do some web scraping, collect your own data set, build your own data set. Then you do all those machine learning experiments. You can follow system designs on different companies. There are different AI companies, how they are doing that. There are white papers that they share for free. So read through them. What are the challenges they face? Try to replicate them. Try to have like a story for yourself, like when you are interviewing for your internship or job, so that you can share like, hey, I worked on this project. I know how it looks like in the real world case because I have these experiences I faced. Also, it always helps if you can collaborate with some group or some team. It can be an open source project. There are a lot of open source communities who work on real world problems, who provide solutions to real world problems. Try to reach out to them. Try to offer your voluntary service, because that's how you will learn. They are industry professionals. So if you can get some advice or get some collaborative work with the industry people, it will help you a lot to understand what are the things, how they're thinking through a problem, what type of challenges they're facing. So try to expose yourself to the real world community as soon as possible.
Thank you so much for wrapping that up. So we're out of time, but a lot of people, they are loving your talk and they want to know just kind of where to go for questions. So where can people find you? Do you want them to join the data science track, or do you have Twitter? How would you like to be?
Sure. So yeah, there are two places where I'm super active. One is Data Science Slack, Women Who Code Data Science Slacks. Please, if possible, join Data Science Slack and DM me. Feel free to DM me with any question. And another place is Twitter. I'm very active on Twitter. So any of those places, feel free to DM me or ask any questions if I have.
Amazing. Yeah, if you can put your Twitter in the chat, Zarreen, when we stop, that would be great. Thank you so much, Zarreen. We're going to briefly stop and then we'll welcome our next speaker to the stage. Thank you so much, Zarreen.
Thank you. My pleasure.